Welcome back, guys. This is a special live stream with Jonny Guru, the power supply expert of power supplies. How you doing, man?
All right, Brian.
Nice to meet you.
Yeah, good to meet you.
I guess a lot of people are wondering. So growing up as a kid, I used to watch or read, sorry, a lot of Jonny Guru reviews, and I love the banter, the humor. That was the best part. So you always just automatically sifted through the search results. Oh, Jonny Guru, click, click, click. Yep. Is it a good power supply? Is it rubbish? That was pretty much the verdict. And what, in your opinion, makes or breaks a power supply? What are the most important things?
So some of the things that people, some of the things that people assume is that efficiency, if like it has a certain 80 plus certification, is an automatic means of quality, right? Where really it's just efficiency. Some of the things you want to look at is actually what the temperature rating of the PSU is. For example, some of the cheaper units, they're only rated at like 25C, and it's never going to be 25C in your PC. Never, it might not even be in the room, right?
Well, with that, the 25C, it's a detrimental thing in itself, because people with lower budgets generally buy cheaper cases,
and they end up, and the ones that come with the cases tend to be rated at 25C. Now, the importance of that is are the parts inside the power supply. They have what's called a D-rating curve, right? And so as the temperatures get hotter, those parts' capability to output declines, right? So that's one of the biggest things. And then, of course, there's a lot of people say, how long is this going to last if it's got these capacitors? And, we talked about this a little bit before. And really, the whole capacitor issue, in my opinion, is kind of overblown. Even the Japanese capacitors you get aren't actually made in Japan. They're actually just Japanese brand and made in China. Because it costs so much to import into China. So all the Japanese companies have factories in China now, and that's who they sell to the power supply companies. But, one thing that's really overlooked is the fan. That's the first thing that's going to die in a power supply.
The fan,
yeah. So it's really good to have a fan that, there's a lot of sleeve-bearing fans out there, and unfortunately they don't last very long, but, it's like a good rifle-bearing fan or an FDB fan or ball-bearing fan, because that's going to be the first thing that dies in that power supply.
It's actually funny you say that, because I deal with a lot of used parts, and that is, I've had to replace fans on power supplies, and they generally, they're dying too. They're like, and then it's spinning in and out.
And it sucks though is when it does die, right? And it just like completely dies and you don't know it. Then the PSU just heats up to the point where it's just dead. I mean, it just blows up. You're done, right? Because it all overheats and just dies. Because that's another thing about a lot of power supplies. They don't always all have the protection circuits, right? The over temperature protection, over power protection, short circuit protection. You kind of take for granted that a power supply is going to have all that, but they don't. They don't always.
So with that, though, I did have some questions with regards to that. Now, I don't know anywhere near as much as you know about power supplies, but I did have two power supplies now that would randomly cut out. Like, it wasn't dangerous. You didn't see any sparks flying up. But when you like playing games and they were rated way above what those parts would juice out of that power supply. So I was wondering, and I ended up replacing the power supplies. The system would work perfectly after that. So would that be too many protections in place, or what would that be? Why would those power supplies just randomly cut out the machine like that?
Well, so really, it depends on the power supply, and we don't necessarily have to get into that. But sometimes we'll see a power supply; it'll just shut down, like a cheaper power supply. It'll shut down when you start up a game or a benchmark. That's a real heavy load because so much power is drawn by like the graphics card or even the CPU through just the one connector, either a PCIe connector or the EPS connector, for the CPU. And that power draw draws so much power so quickly that it causes a drop in voltage. And then the power supply has under voltage protection. It sees that the voltage is dropped and it goes, whoa, something's wrong. Boom, shuts off.
Wow.
So it's So and unfortunately, I see it a lot of times with these guys that build systems for a living. They tell you, oh, I got this graphics card, this CPU, this much storage space, this much memory. They never tell you what PSU's in there, right? And then they put like two GTX 1080s and they got a $40 power supply in there, and they're complaining that the PC shuts down when they fire up, just 3D Mark, right? And it just shuts down.
Or they're complaining about this sudden incense in their room, like the incense, the smell. Okay, well,
what's that smell?
What's that beautiful smell in my room?
So it could be the under voltage protection, and some power supplies have over current protection. It's rarely that though. That's when if too much current but it's sustained current, right? So it's like it would have to be like 30 amps continuous draw, and then it shuts down. So it's probably not OCP, but it's another, like you said, it could be any one of protections. It could be just a cheap power supply, or it could just be protections that are hypersensitive, right? And that includes OTP too. Like I said, if the fan dies and there's OTP, the PSU is going to shut down. Or if it's just a really hot environment, I mean, you know, if it's 35, 45 degrees inside your PC, and the power supply is just going to freak out and shut down.
Well, I do remember I used to have a Seasonic power supply way back, and that was blowing out really hot air, and that did it for years and years, and it never had a problem.
Well, but that's a good thing though, and it's kind of you kind of think that it shouldn't be blowing out hot air, but what that's actually telling you is that it's doing its job evacuating the hot air out of the power supply. If you weren't getting hot air out of the back of the power supply,
and you're juicing a lot of
that
power,
means it's just staying in the power supply, right? You know, so that's and a more efficient. I mean, the thing is you know, when AC is converted to DC, obviously the byproduct is heat. You know, so the more efficient power supply, the less heat it's going to produce, right? So it's not like if you have two platinum power supplies, one's not going to run hotter than the other. But if you feel that one of them has hot air coming out of the back or hotter air coming out of the back than the other, that just means it's moving that air better.
So I have a question though with regards to this. You know, you've got different power supply designs. Now, old school, it used to have the fans sort of pushing air in that push, sort of just push, and that was
the ones with the fan and it pushes across. Yeah.
So, and now you've got the fan blowing air up. Which, in your opinion, is better?
Well, obviously pushing the air through is more efficient. But it's those 80 millimeter fans are loud.
And they're loud.
And quiet is like, you know, so important for people. More than ever. Everybody wants quieter and quieter. You know, water cooling is actually making a comeback. Before, you know, it was like because it was cool, and now it's because it's, you know, it's quiet, right? You know.
So, do you think we'll ever see a water-cooled power supply?
I've already seen. I've already seen a bunch of water-cooled power supplies. You know, 10 years ago, Coolants made a really cool water-cooled power supply. I had my machine. It was basically a mineral oil bath. The PSU was all sealed in mineral oil bath, and I think Bits Power has partnered up with FSP, and they have water blocks on an FSP power supply right now. So yeah, I mean, it's kind of that's kind of a weird thing because power supplies don't get hot enough really to justify having to water cool. I mean, like if you look at some of the Corsair power supplies with the 0 RPM mode, I have people freak out all the time. It's like, oh my god, the fan never turns on. I'm like, you know, well, what do you got? Well, I've got like, you know, a 11060 card, and I bought a 1,000-watt power supply. I'm like, that fan's never gonna turn on.
It doesn't matter what you do.
I mean, I don't care what you do. It's never gonna turn on because that power supply is never gonna get hot enough to justify using a fan.
Plus, the efficiency's right up there.
That's what I'm saying. Yeah. So, and like I said, if you had, you know, the two power supplies are the same efficiency, one is not going to be hotter than the other because that AC is going to get converted to DC, and that efficiency difference, that's your heat.
That's how I learned it from your articles.
Cool.
But a lot of the time too, when I look at a power supply, like I use in Japan, bro. When I was hunting for used parts, I'd use a lot of like a Delta FSPs. These guys in Japan, they were selling these things so cheap, and they didn't know their value. And they're 500-watt power supplies.
The used ones,
the used ones, and you can't really get those deals in Australia or US or because. I don't know. I've looked for them a lot and I can't find them. But in Japan, they're just dime a dozen.
Wow.
And so a lot of people will be like, "You're using a $10 power supply. It's garbage." And it's like,
well, not if it's a Delta. Or, you know, I mean, if you got a brand name, I mean, a reputable tier 1 brand, you know, you're fine.
And that's what I was trying to explain. I was like, guys, this is going into servers,
right?
It's not garbage.
Yeah, that's the thing. If it's a server, server power supplies are, you know, mission critical, right? They're made to not fail. They don't necessarily always have the best voltage regulation or minimal ripple. That's all consumer level product because consumers read reviews and it's like, you know, this guy makes a great power supply. Now the next company comes along, they have to make it better so they can get a better review. And so we see power supplies leapfrogging themselves every year as far as performance. But servers, it's all about efficiency and longevity. And that's it.
But with that said, what can get better on power supplies? I mean, we're not talking RGB lighting. I mean,
so a term that gets used a lot on JonnyGuru.com is I can't remember this. I'm sorry, I'm tired.
That's okay,
Mythic
Yeah.
performance, because we're to the point now where it just our voltage regulation and our ripple is so so mythic. There we go. We use that word again. That it doesn't even matter anymore. Right. Yeah. So now people, and we're seeing it this year, right? They're looking for little niche things to do with their power supplies to make them different. RGB lighting, water cooled, you know, stuff like that.
So the ripple's basically gotten to the stage where can it get a lot better, or it's so tight?
I mean, so the thing is, right now it's so tight. I mean, when you're down to 20 millivolts, you can't differentiate if that's coming from the power supply or if that's just line noise. You know, it's
on
just
the actual
so
line.
it's just so anything that's 20 millivolts or better, it's a blurred line, right? So.
And so that's also a critical factor in getting the extra overclocks. Like you've got people talking.
Well, yeah,
about,
because
say for instance, I've seen other people review products and they're like, this motherboard got an extra 100 or 50 megahertz, and then they've used a different power supply though.
Yeah.
And I've known in that the better, you know, the better suppression and whatnot, the better the closer that tighter that line is, the better it is, right? And so that helps with overclocks.
Exactly. No, it does. It really does. That and not to brag, but that's why a lot of the guys like using the AX1500i. I know that sounds like a plug, but
no,
but when they don't, when the power supply is not sponsored, right? And the overclocker brings their own, it tends to be the AX1500i because it's digital and the ripple's just so, you know.
So
clean,
tight,
so clean.
So you designed which power supplies at Corsair did you help design, or? Let's talk about those because we got to know this. So I want to know. So the AX1500 was your design?
No, actually no. AX1500i was that was beyond me. I mean, because that was like the first digital power supply. If you told me that you could replace all the analog ICs in a power supply with a bunch of microcontrollers, I would say that sounds absolutely nuts. But the engineers at Corsair pulled that off. I actually came in after that, so you know, stuff like the SF series. I was part of that team, and of course the the HX and the TXM. Everything that you've seen launch in the last couple of years, and then of course, you know, I always have to go back because I'm like, oh man, I found this mistake, this problem. So go back, refresh the product. So that's why you always see us with new product every year. There's a reason for that, because we're trying to be everything to everybody and make everybody happy. So if somebody has one little nitpicky complaint in a review, and a lot of people say, oh, that's just nitpicky, it's my job to go back and fix it for the next time around.
But that's the thing, and that's what I like about Corsair, guys. I've spoken to them about little things that I didn't like. For instance, the 460X, there was some things I didn't like about the case, and they've listened to those people. They're going to be refreshing that and making things better. So they listen, and they really
that's the cool thing about the environment at Corsair. You know, we've got all the different product managers. They have their own specific product, and they own that product, right? So if they get feedback, they have to follow up, right? Because it's like that's their job. Their job is like, okay, this is my baby. Now you're insulting my baby. You know, so it's you can't have a big ego, right? Because you have to be able to say, crap, you're right. I gotta fix this. Right? You know, whatever it be, cases, coolers, power supplies, whatever. You know, you have to have an attitude that's positive.
Everybody makes mistakes.
So make it better.
People are watching me for a long time know how many mistakes I've made. I think I make a mistake every single day of my life.
Cool.
I get guys in the comments, you are a mistake, Brian. Okay, that's going a bit too far. But so we had some questions from the audience. Which SU is best for an all? No, I say SU. Is that fine? That's real casual Australian in me.
What is it?
SU instead of PSU. I just say SU.
That's cool. No, I never heard that. But I do know that Australians like to abbreviate everything. Brekkie for breakfast, Sunny for sunglasses. Yeah. So I should get used to that. But, okay, SU. Got it.
So here we have it here. So which SU is best all-rounder? And I'd say what for a budget, right? I guess a lot of people are buying a GTX 1060, RX 580, and of course you'd be buying maybe R5
I could tell you to buy the most expensive Corsair power supply, and that would make
that wouldn't.
But the thing is, and the sales figures show that the RMX has been the proven most solid. It's very low failure rate. It's only gold efficiency, but like I said, it's, you know, you're talking 2% difference, and it has a 0 RPM mode that works really well because it actually uses a microcontroller. Corsair's like, I believe, the only company that makes desktop power supplies that uses a microcontroller for the fan speeds.
Oh, wow.
So we can actually program the fan profile in there, what RPM to start at, how to ramp up, and stuff like that. So RMX is our least expensive unit that uses the MCU for the fan controller. Fully modular, of course, and now we have the individually sleeved cables that we sell separately. You can customize the colors, and now we're shipping it in white. I'm sure you saw that this week. We have the new white ones, and it comes with the white cables too. Because the demand for that was just so high. We did a limited edition of the RMI, the RM1000i, and they were all gone like in under a day.
Wow.
And then everybody was just like, oh my gosh, I got to have this thing. So we did the RMX because it's more mainstream. So I would say, you know, overall, just the best bang for the buck, I would say, is the RMX.
Out of the Corsair line?
Yeah. Okay. Now, I use an RMI, but that's because I'm kind of geeky about wanting to monitor power consumption, voltages, and stuff like that.
That is a good thing with the digital link via USB too. I've got... That's the problem at the moment I'm having. I've got 3 digital Corsair products, but only 2 USB headers. So I got to figure out which one to hook up. So because I got the lighting, the RGB lighting, the cooler, and then the power supply.
What I ended up having to do, I got a PCIe USB card, and I plug everything into that. Because
we do have to address one thing. Because a lot of my viewers talk about the VS series. Yeah. We have to talk about the VS series now. I get a lot of people who they say it's crap. I've used the VS power supply. I've had no problems with it. The VS550 is that it's a budget entry level power supply. Yeah. And for me, it's always done the job. I use 2 of them now in budget builds.
Yeah, I mean, so you can say it's crap because it is the least expensive Corsair power supply you can buy. But we do have to maintain a standard. I mean, you see there are a lot of power supplies out there that aren't even 80+ certified. Might not even have active PFC because it's not required in every country. It's not required in Australia. It's not required in Australia or the US, right? And it's you know, and so it's the least expensive. It's totally no frills. But it works, you know. It totally works. Yeah, it's not modular. It's only a sleeve bearing fan. Only has a 3-year warranty. You know, there's reasons for these things, but you know, if you got to hit a certain price point, then, you know, there it is.
Well, yeah, I mean, and especially consider 550 watts is actually a lot of power.
It is. It's way overkill. I mean, unless you're running SLI, most people don't even need that much power.
And if you're running that 550 watts of power, arguably you'd have expensive gear and you wouldn't want to put a VS550 on there anyway. So that was my argument for me is like, okay, you're putting this with a 1060 or 580 and a mid-range CPU, and that generally those configurations will juice maybe 250 watts when you're gaming. Right. So it's like that's well under the 550 watt limit. The power supplies are going to be sitting there.
Yeah. And that's why I like the RMI series, for example, is because you can actually get actual data, numbers that what your actually power consumption is, because even though you can't see the link screen if you're running benchmarks and stuff, it does have the logging capabilities. You turn that on and then it creates a spreadsheet for you. Okay. And then you can pull the spreadsheet out and see what your power consumption was while you were benchmarking and stuff like that.
So I noticed I noticed lately I've been Mafia 3 has been breaking the because I thought Crysis 3 was the game that stressed the whole system the most at once. Yeah. And then sure enough, Mafia 3 is now the king for me. Like for
I haven't tried it. Yeah, for me, I think the latest one I found was a major power suck was Witcher 3.
Witcher 3, okay.
Yeah, but I'll have to try Mafia.
Yeah, definitely. I have to try Mafia, so I think that's the way to do it. But we got some questions. So we got, I think someone wanted to
someone say, how do you measure ripple? Yeah. You need an oscilloscope for that.
You need expensive gear. And so
the oscilloscope doesn't necessarily have to be expensive, but you'd have to measure it with a static load. Otherwise, it's just going to jump all over the place. So, you would need like a load tester, which is expensive. That's the expensive part.
Okay, now one question I have, is it better to be under the voltage rating or over?
It doesn't matter.
So, like, if you're at 11.9 versus 12.1.
Doesn't matter. Okay. So what you want to look for is how much the differentiation is from a low load to a high load. Okay. So if you're always under 12 volt, but let's say your drop is like 11.8 to 11.79, I'd rather have that than a drop from 12.3 to 12.2, right? I don't care if it's above or below, because the thing is you're feeding that power is going to power regulators on the motherboard and the graphics card. It's got a wide range of capability to convert that power down to what it needs to be, right? So it's okay to feed it power with a plus minus of like 5%, but the thing is you want to make sure that power is stable, because as that power fluctuates, it takes those FETs a while to cycle the voltage where it needs to be.
I mean, call it a bad analogy, but it's kind of like the throttle body. If it's not stable, kind of thing, the car's like trying to take off. I don't know. That's how I kind of think
you want
it.
Nice and smooth, right? And that's what you want. You don't want these sudden spikes and drops and stuff, because that's going to hurt your components down the line. Right?
So what if you overvolt though severely? Say you got like 12.7 or what? I have seen it before.
I know.
On a bad power supply, I've seen like 12.7 on the 12 volt.
Yeah, if it's that high, that's not good. Because like I said, so you've got those components that you're feeding power to, they have a tolerance, right? And that's why the Intel spec says you need to be plus minus 5%. So 11.6 volts to 12.4 volts is where you want to be. Okay, no less, no more. And so so if it's too high or too low, the reason why Intel defines that is because they know if you're too high or too low, that's going to stress those components. They're going to freak out, because they're like, well, this is more voltage or less voltage than I can handle, and it screws everything up.
So you'll be making pop culture, if that's
pop culture,
amongst your friends in the tech scene, So we got some questions. Someone asked about EVGA B3. Is that I don't know? Just asked. They said ask him about the EVGA B3.
It's based off the Superflyer Elite X2.
Yeah, so it's good. I had a Superflyer Plus, so it's pretty good. Yeah, and so there's a lot of good power supplies out there.
Oh yeah.
So
what it comes down to a lot of times is what kind of support. If it's a brand name, I mean, let's put that out there too, because especially like in Europe, man, there's some like totally random brands I've never even heard of.
They are popping up too.
Yeah, because I see them in the forums, right? It's like, hey, I got this, Butch Cassidy brand power supply. What do you think of it? I'm like, what the hell?
Well, I did hear. But
if it's a brand name, it's like you want to, do they have good support? Do they have good warranty?
Yeah.
Is it if you do you get a 10-year warranty, or do you get a 1-year warranty that you have to register? Oops, I didn't realize I forgot to register. Now I don't have a 10-year warranty.
Yeah,
stuff like that.
And then they're allowed to advertise 10-year warranties.
So that's the kind of thing that people need to look for when it comes down to the bottom line. And also support if you have problems, like somebody that can help you troubleshoot if you're having an issue.
That's true.
Do they even have support? Do they have a phone number or stuff like that?
That's true as well. So I had a you're probably gonna hate on me for this, but I because I deal with a lot of used power supplies, I spliced in wires, and instead of finding those modular connectors. So I wouldn't have the gear at the time to actually measure the voltage, and I was in a rush, and I'm like, okay, I'd be splicing off the 24 pin to get the SATA connections. Very, very odd, but it did work. I never had a problem with it. So, and it did work, and it was very odd. But also on that note, I did make my own, troubleshooted my own extra CPU connector modular, and took it from a PCIe connection, rewired it, made it a CPU.
Yeah, reversed the...
and then made it a CPU connection. So I've never had problems with hacking power supplies, but a lot of people tell me I'm going to electrocute myself. But what's the best way to, when you're dealing with power supplies, what's the best way to, if you have to work on them, what would be the best way? I've always...
The DC is not going to hurt you, right? So, I mean, the only thing that's going to really hurt you on the power supply is that bulk capacitor inside. Okay. So, I mean, just don't open it.
Don't open it.
Because if that thing is charged up and you open it up and you touch those contacts on it, you're dead. Yeah. It's 400 and well, it depends. 420 volt, 440 volt, and you don't want to mess with that. But and there has been people that have gotten killed. I've seen it in the news.
There's a YouTube video of a dude shooting back halfway across the room.
You don't want to mess with that. But the DC voltage, you'll be lucky if you even felt a tingle.
Okay, so basically,
and just hold on to the wires. You're not gonna feel.
But to drain a power supply properly, I've always just turned it off from the wall and then actually press the power button and let it drain out.
Yeah, the best thing to do, and it's a lot of times, and this might be good information for your viewers. When you turn off your PC, and even if you flip the switch on the back or even unplug it, right, and you'll see that the LED is still on your motherboard.
Yeah.
Okay. That's just because the power supply is still charged up, and that LED, if you don't have much of a load on there, that LED can stay lit for like 15-20 minutes.
I've seen it like a long time. I'm just sitting here like, whoa. One time I fast forwarded it, and it was like a good 3 minutes. And because they had multiple LEDs, and they're just staying on, I'm like, wow.
And so everybody's freaking out. It's like, oh my god, there's something wrong with my motherboard. It's the power supply is doing what it's supposed to do. because the capacitor that you want that capacitor to stay charged, because if your power goes out, the PSU can actually keep running until the power comes back on. Now we're not talking like a blackout, but like if your power dips or something like that, like when the AC turns on in some old house and the voltage goes down and stuff.
I've seen
the
that
PSU will
with
keep
the
running.
vacuum, with the vacuum cleaner. I remember
vacuum cleaner, air compressor, anything, with a motor.
I remember when I was a kid, I had my cheap computer. Mum would turn on the vacuum vacuum cleaner, and the whole computer would just turn off. I'm like,
right, and so that's hold up.
sheesh.
That's what hold up time is for. That's the whole thing about hold up time. And that hold up time, the whole definition of the hold up time is how much power can that big cap in the power supply, the bulk cap we call it, can hold a charge. But like going back to that, it could also kill you.
But yeah, it has. I guess it's a double-edged sword, because if it's too much, it can. Is it the inrush current? It can.
No.
That?
No, it doesn't affect. Well, it can affect the inrush current, because if you have no AC power going to the power supply and you flip the switch on it, or surge protector, then that's going to cause a rush of current to charge that cap, right? So that in itself could cause a problem. It's really rare though that causes a problem, because there should be the proper circuitry in the power supply to prevent that from being a problem. But to go back to so what you want to do is, I mean, like I said, you can have that PSU turned on and plugged into a motherboard for however many minutes, and that cap will still be charged. So the best thing to do is just have some kind of load on there, a fan, a hard drive, something to just drain that down.
Just have a fan on. Like, I've never thought of that. Just have a fan to drain the power supply.
Until it's completely drained.
Power supplies. They're dangerous things, guys. Don't do what I do. If you ever seen my used budget builds, don't do what I do. I'd be like I'd drain the power supply, I'd open it up, and I'd spray parts cleaner on it, clean it all down, get all the dust off. Thing would work like brand new.
Sure.
But people tell me I'm going to electrocute myself. It's like, as long as it's not charged,
right.
as long as you make sure the power supply is got not a single bit of current in there. So, I mean, if we talk about an LED being lit for 3 minutes, or 15 minutes, that's enough charge to kill a human being. So because the charge runs through your body. Have you heard, what's the worst story you've heard about? If
a guy in China just died. I mean, he just got shocked and died. He opened up his power supply, and but he was really dumb about it, though. I think it was still plugged in, is what the story said. So.
Wow. Okay.
So he probably got it from both, from the wall, the cap, he just completely messed up. But
that's a pretty weird one.
But but that it'll throw it, at the very least, it'll throw you back.
So do not open up your power supplies, guys, unless you seriously know what you're doing. So or you just
you really know that it's,
or you really have to open up a power. I mean, you shouldn't. Generally, it's either dead or you want to.
Yeah, if it's out of warranty and the fan dies, right, and you want to replace the fan, and a lot of the really techie guys, they'll do like full cap replacements on them.
Oh wow! Like that, so what's with the caps? Sorry, if we talk about VS550 with the caps, right? If you ran that thing 24/7, say for instance on a 300-watt load as a gamer would on a VS550, how long would it take for those caps to get bigger and blow up? What would be the average outlook on the life?
That's kind of so we do a cap life analysis on all the power supplies, and that's pretty much how we determine where warranty should be at. Because there's a formula that you can use based on data that you get from the capacitor manufacturer that says if you're running at this temperature 24/7, with this load or whatever, this is how long that cap's going to last. Okay. Right. So, the easy answer for VS series is going to be 3 years.
3 years. Right. Okay, it running
24/7 full load. Yeah. I mean, that's we have to determine a 24/7 full load because we don't know what people are going to do with our power supplies.
Well, and if you're playing on your computer 24 hours a day, you're seriously doing something wrong. Like
win the lottery, and that's like all you have to do now is just play the game, play games all day.
Don't do it, guys. But 8 hours a day max, and even then, that's pushing it. So that was when I was young. I did the big sessions, 16 hours on World of Warcraft. That was bad. Did you play World of Warcraft?
No, I stopped at Warcraft too. I couldn't get into.
I'm glad to hear that. That game was
I'm more of a FPS guy.
Oh yeah. So what games do you play? Like let's talk about things.
Overwatch is the big one right now. Yeah.
So what character do you play in Overwatch?
I just go all over them.
I like Junkrat.
Yeah,
he's my favorite at the moment. I play a bit of Junkrat, and you just run around because you can kind of you can get into places that people camp and do their little snipes and stuff, and you can kind of get in there without being seen.
Yeah, I'm looking forward to the Quake Champions from finally. I was on the beta, but I could never get on the darn server. It's just like, oh yeah, here's the beta program, download it. I'm like, all right, cool, fire it up, and it's like, sorry, I can't get to the server.
And so, what about gear though? What does Jonny Guru use in terms of monitor, graphics card, CPU?
My monitors are actually pretty low. I've got the Samsung 120 hertz, 20. What is it? 2024. I got 3 of those.
Oh
boom,
yeah,
boom, boom.
120 hertz. So you like the difference between 60 going up from 60 to 120?
I can tell.
I think a lot of gamers, like people who play PC games, can tell.
Yeah, I can tell.
Yeah, and I've tried the 240 hertz recently.
Yeah.
That was crazy. That was really crazy. It was actually really nice.
Yeah, so one of these days I want to get like a curved monitor though. So
I've got one of them, the Samsung, the CF7. I'm not going to... my viewers know I talk about the Samsung wide too much, but...
I really want one. Although
really
I did see that Dell 8K.
Yeah. But do you think... I think with monitors, right? I think with monitors... Okay, so what about monitors, though? How some of them have their power supplies built in, but they only juice such little amount of...
Yeah, they don't pull much power. So,
but what's the usual?
I don't even like them. So my Samsungs, they all have the internal power supply.
Okay,
right? You just plug the power. It's so convenient. I hate the power bricks sitting all over the floor.
But you know, the funny thing with monitors, I find the actual display outs die before the like if a power supply was there. And why would you know why the display ports would just die? Like it's bizarre to me because like I'd have a DVI port blow out on a monitor and the HDMI works, so it's still okay. But
I have no idea. I mean, you know what? I do have some idea because if I apply some of the power supply knowledge to that, I mean, there's things like when you have surface mounted components, we run into this a lot with power supplies. Yeah. If they're mounted on both sides of the PCB, right, and you float it through the wave solder, but then you have to put in a jig and get it assembled the rest of the way, you can actually crack the components on the bottom, but you don't crack them so it's a complete failure. It's like an intermittent failure, or it's going to fail in a matter of time. And when you look at it under a microscope after you take it apart, and you'll see that just that connection of a resistor or a die, it could be anything. It's severed.
So could that be where that oven could fix it or not? Usually you got to you actually resolder broken joints properly.
Well, no, actually, so Jeremy at Jonny Guru, he does a lot of Bitcoin mining, right? Okay. And he's always frying graphics cards, but he just throws them in the oven, heats them up. They resolder in the oven, just a kitchen oven. Yeah. He pulls them out and they work.
Wow.
So it's like, all right, man, whatever.
That's it. But he's done it before because I've tried. I mean, I don't know the technique properly. I just shove it in the oven, and then I've seen one time I saw the PCB
so you know the trick.
Bright orange, and I'm like, well, this is a bit too much. Cooked it a bit too much.
Yeah, but it does work, and not all the time, but it does work. So if it's dead, it's worth a shot, right? Because you're gonna make it worse?
Yeah. What do you got to lose? I mean, I guess if the silicon's dead, which is a different story.
Yeah.
If you've warped the silicon.
But you know what? I mean, I'll have to tell you what, the likelihood of the actual silicon parts dying, same with the power supply, right? Yeah. Is so rare. I mean, when I see power supply failures, it's typically just parts that just they come apart. You know, they come off the PCB. They separate from the PCB and stuff like that, or they short to another part because they were not correctly oriented or whatever, because it's not a fully automated process to make these things, but you do have, they call it the pick and place machine. It puts all the small parts in there and it has to go through that wave solder, and you try to make sure you have a jig that holds everything in place, but it's not a perfect process.
So what would be the worst conditions versus the best conditions? Like we're talking about humidity maybe, or a drier environment would be worse for cracking things. I mean, I don't know these. I just guesstimate that a more humid environment would actually probably be better for your parts.
Yeah. No, I don't. I don't think humidity. Well, so there are humidity ranges, and so like if you go through one of our technical documents, they're internal, but I'm just saying if you did, there's a thing for altitude requirement, temperature, humidity, and stuff like that. So as long as you're within those parameters, actually none of them have an effect. And really, the thing is was it built right in the first place? That's all it comes down to.
The protections, like the coating on the PCB.
No, I mean actually, the process of actually building it, not the design. Okay. I mean, obviously the design is huge, right? You can slap together, the cheapest power supply in the world, and then build it perfectly. but it's still a cheap, crappy power supply. But I'm just saying, even if you have a fantastic power supply, and one thing goes wrong during the assembly process, you know, 3 months, 6 months, 1 year down the road, something can fail, because like I said, you can have just like a tiny little break in the solder or a crack, or
and
you
it's
know.
gone. And then of course, if you live near the ocean and you leave your window open,
Oh God, yeah.
Don't
No,
do
I
that,
used to
guys.
live in Florida. And, back in the day when you know, you'd have a dim and it had the gold contacts and the tin in the slot, and then the corrosion would literally weld the memory into the motherboard, and it's just like, oh my God, you know, you can't even get the thing out of there. You just see a line of rust. You know?
That'd be brutal.
It's horrible.
So, there's one more question I was going to go, but I had a brain fart, so I completely forgot. But we can go to the viewers for some questions. I'll try and refresh. So if you guys have any questions for Jonny Guru, then be sure to ask them. I mean, a lot of these guys, they love the used parts as well. They love new parts, of course. But what's the most, actually, because we're talking about the 290X or the GTX 480, what was the most single power hungry card out there? Because I think the 290X comes pretty close.
Yeah,
the 480 GTX 480 was pretty.
295X2.
Yeah. So, what's the most power hungry graphics card?
You know what? Seen? It's funny. So I actually built a machine back in the day. God, it must have been. Well, to give you an idea, I would have to say probably 8800 GTX. I mean, I know that's going way back, but I worked for BFG.
Yeah.
And I built a machine with the sole purpose of consuming as much power as possible. So I had the, you remember the AMD bulldozer? Or no, wait, what was it called? The, not the bulldozer.
The pile driver?
I don't remember. It was a dual CPU board.
Yeah.
With two 8800 GTXs. Yeah. And I'd run benchmarks on that thing, and believe it or not, I would pull 1,000 watts from the wall.
Wow.
Yeah, it was crazy.
Whoa, that's huge. I've actually never seen 1,000 watts from the wall.
Yeah, it is crazy. So.
But also got one more question.
But the Bitcoin miners though, they do it.
Yeah.
And now with the value of the Bitcoin going up, I am seeing high power supplies flying out the door because, like the ASIC miners.
Yeah.
You know, they used to be, people use ASIC miners because they're more efficient than graphics cards and blah, blah, blah. But now you have ASIC miners that use 1,600 watts for one ASIC miner.
Wow.
Right?
So they've gone through the roof. Wow. So remember they were low power, but now
they were low power. And now the ones they're using now to really mine hard is 1,600 watts for the one miner.
So I hear people are mining other cryptocurrencies now with the graphics cards.
Yes, because you can so like I was saying about Jeremy and throwing his graphics card in the ovens, he does altcoin because he can use the graphics cards. Yeah. He doesn't pay for power. So
he runs them at the Corsair office. Or?
No. He lives up in Canada. Although we did do that once. So he does altcoin and he uses graphics cards for that, and he just recycles them. You know.
So one thing I am curious about though, with the power supplies, is there many people who do DIY, like they get all the components and build the power supply themselves? Not that I know of. Yeah, so could you? Is there something like, for instance, with a chipset, of course you got something holding you back like a motherboard, but with, say, for instance, a power supply, would there be things?
No, if you could get all the parts, you can do it. I mean, because so the most, like something like a motherboard, you have like a 4-layer or 6-layer board, and there's traces in between and stuff like that. Obviously, a home person can't build that, right? Yeah. But a PSU PCB is typically only it's either single-sided or double-sided at the most. Yeah. Right. At the most, it's double-sided. So. Yeah, it's theoretically you could do it if you could print a PCB for it and make sure you get all the right components. Yeah,
you could do it.
But it's the thing is, it's more time and money than it's worth because
I know.
it ended up costing you so much darn money.
Well, I've seen people building their own keyboards, and that's my initial reaction. Like, whoa, that would be a big waste of time. So.
Yeah. No, I think it would be cooler to just like mod a power supply, like, instead of.
Okay, so do people do that? Like,
not so much. It's funny too. Actually, I would think that is fairly, that would be fairly common practice. I mean, I see people that paint them and stuff, right? But cut a hole in the side, put a window in it, or even like we were talking about the water cooled ones before. Open it up, take the fan out, put water blocks on top of the heat sink, drill a bunch of holes in the housing for additional airflow, and
Yeah.
Say, hey, look, I just made a water-cooled power supply.
Here's a very specific question too. So this one, so we're going to look through questions, guys. Sorry if I miss any. I'm on a laptop monitor, so we've literally got like a little screen for the stream. It is pretty tiny, but it has been really good laptop. So looks like a very specific question. Ask Jonny. Oh my guys.
About modular.
About modular versus fixed cables in voltage variation or efficiency.
That is a good question.
Yeah.
So obviously, any point of connection is going to be
an efficiency drop.
Right, an efficiency drop. Because you have it adds resistance, right? Yeah. And the pins, everybody's like, oh, the gauge of the wire, and, the number of connectors. The pins are the part that's actually the most susceptible to high current, right?
Yeah.
So when people do things like, and it just drives me up the wall, they use adapters like a Molex to a SATA adapter or something like that.
Yeah.
They're putting stress on those pins. It doesn't matter what the gauge of the wire is or that you've made it like 50 feet long. I don't care.
Yeah.
You're stressing the pins out. So on a modular power supply, then that's like 10 times worse, right? Because you have the pins where the cable plugs into the modular interface.
Yeah. And obviously that's the point of where the most power is going through.
Because everything that's plugged into that cable has to go through that connector, right? So I had a guy just last week ask me, he's like, how many hard drives, platter drives, can I plug in? Can I do 7? And I was like, how many connectors are on that the cable now? And he's like 4. I'm like, then 4. Okay. Because
because you don't want to overload the
right. And with the power, and I can't speak for other companies, but with like Corsair, for example, we choose the gauge of the wire depending on how many connectors are on there too. Yeah. So if we only have like a couple connectors on there, we can get away with like an 18 gauge wire. But if we have like 4 or 5 connectors, 16 gauge, or I'm sorry, I'm going backwards now. 16 gauge, 14 gauge, a smaller number, bigger wire. So the thing is, so you don't want to screw with that engineering and say, I'm going to start adding connectors to it, because now you've just completely thrown that out the door.
Because in a way, I've been a fan of semi-modular, because you kind of have to have your 24.
Yeah, you got to have the 24 pin and the 8 pin anyway.
Yeah,
right?
And so so do you think the semi-modular designs are kind of like the best, I guess, for both worlds, like for the perfectionist?
Yeah, well, I mean, obviously, it goes without saying that's going to be less problematic than fully modular, right? Yeah. And fully modular is going to be worst case scenario because the potential of connectors to go loose, the potential for the pins to fail, what I was talking about before. And obviously semi-modular, you won't have that problem. Okay, at least with the 24 pin and the EPS, right? I do like fully modular though, because if I'm changing things on my PC, I just click, I just pull them all out, and then my power supply is just a box.
It is pretty fast, So that's true. Okay, we'll go to the next question. So, who we got here? So, okay. Ask Jonny if there are any problems with wine with the RM1000i.
You know what? Actually, in this day and age, every power supply is susceptible to coil wine, because they have to have the... To get the better efficiency, they have to lower the switching frequency down to almost audible level, right? And so if those parts that are wound, whether it be a coil or transformer or even a poly capacitor with the plastic, if they're not made absolutely perfect, and this goes back to where I'm saying, where it's like perfection's impossible, so you never know what's going to happen down at the end of the line, or not never, but you hope that everything goes perfectly. That then you end up with these vibrations, and those vibrations cause audible noise. And so in the engineering department, we go and we attack, and we're like, all right, cool, everything's perfect, and then 6 months down the road, something happens because the capacitor manufacturer, the coil manufacturer, something like that, they hired a new guy and he did something wrong, or he didn't put enough, the lacquer on the coil or something like that, and then boom, all of a sudden somebody's complaining about coil wine.
So that is actually a funny thing with design sort of changing. It's not your fault, like.
Back in the day, you could have really high switching frequencies. That's why old PSUs like, man, I had a Intermex power supply from 20 years ago and never made a noise. I'm like, but the efficiency was like 70%. The switching frequency is so high. If it was making noise, you could have the crappiest parts in there, you wouldn't hear it. So it's just it's just technology getting ahead of itself.
So we'll start finishing up the Q&A. I like this question. What are some good rules of thumb when you're buying a used power supply, or you're just buying a power supply? What's some just general I mean, mine would be stick to the solid, reputable brand names, especially with a power supply. There's no room for. It's the one component that if you have problems, the potential for a lot more problems is catastrophic.
Yeah, exactly. So definitely don't get something that nobody's ever heard of. You know, you can't find a review for it. There's a reason for that. It's because the company that made it never sent any units out for review. And then the thing is like I said, the fan type. If you want to make sure, if you don't want to have to take the thing apart and replace the fan, right?
Yeah.
If you know that it has like a ball bearing fan or an FDB fan or something like that, like, you know, going back to what we started with, the fan is going to be the first thing that fails in a power supply. Yeah. So if it's a good fan, then you know that you're going to get some mileage out of that power supply, even if it's used.
So you'll be home and hosed, yeah.
And unfortunately, though, you can't tell things if you're buying it used. You can't tell how hot the guy ran it. So that's the thing, because you know, like if you run it if you run a power supply in extreme temperatures, those caps are gonna bulge. But that's another thing too, is you take a flashlight, shine it in the grill,
have a look.
You can tell because you know they have the vent cuts in them and they'll split, right? Yeah. And you might see a little bit of the electric lytic, you know, coming out of the top or something like that. So if you see that, then it's like, oh, you know,
don't buy that one unless you know how to replace the.
Yeah, because that would be because of high temperatures. Because if the power supply is not that old and the fan still works, but the capacitors are bulging, somebody ran that thing way too hot.
Yeah, and so with that, say for instance, this will be my last question with a refurb, right? When something fails, how likely is something else going to be near failure because of that original failure? Say the cap blows out or something. Is that? That's
a good question. So that's a dangerous thing too, because so if you have a cap that's completely bulged out, but the power supply still works, right, and you don't know it, okay, then that's causing things down the line to not run correctly. Right, the ripple could be like 5 times what it should be and stuff like that, and that's when you end up with power supplies that kill other parts. And you're sitting there freaking out, going, "What's going on?" It powers, and that's the thing that bugs me about power supplies, is that people assume it runs, it works. But the thing is, it's like it runs, and you could have just killed your last 3 motherboards. Like, hey, I can't figure out what's going on. I'll just keep replacing my motherboard. Hey, maybe it's your power supply is killing everything. I mean, I used to do tech support. I used to be a manager in an RMA department. And we'd have people. I mean, the whole reason I started JonnyGuru.com was I was in an RMA department for an e-tailer, and there was this guy who bought all his parts from us except for the power supplies because he thought our power supplies were too expensive. And what it was he'd return all the parts after a year and they'd all be dead. And you know, and then it's like, dude, bring in the whole build, let's check it out. And it was some power supply I never even heard of. It weighed like nothing. It was just this flimsy steel housing, not even painted, no sleeve cables, just the cheapest thing you could buy, right? And I'm like, okay, well, I think this might be the problem. He goes, no, it powers on. It's fine. Everything powers on. It's not the power supply. And so then I found a guy in the industry who had a load tester, and we put it on there, and we hooked up an oscilloscope to it, and the ripple on it was like 300, you know. It was
roller coaster.
Oh, yeah. And I was like,
don't do that to your PC parts.
And I was like, nobody does this like for reviews and stuff. So then I'm like, dude, how much can I buy this thing for? And I bought all the kit, and that was it. So,
So yeah, I've always inspired to try and review power supplies, but is it time consuming? Like it would be.
Well, the time consuming part is actually running all the tests for X number of time. I mean, if you want to be thorough, you want to do like we do 10 tests at JonnyGuru.com, cold and hot, so it's 20 tests total. You're gonna want to run it for X number of minutes per test. So it can be time consuming.
Okay, and actually, one more question from me. Because I got him here, guys. I want to ask so many questions because I want to get refreshings. If we've got, so there's the phone, so maybe it's time to go. One last question, final question.
No, that's good.
If we've got, say, for instance, 100 volts,
I don't even know what that means.
Yeah, 100 volt from the wall, versus 240 in Australia, which would be better for a power supply? All other things
the 240.
considered.
The 240.
Okay, and why is that?
Because higher voltage, lower current.
Okay.
Lower current, less heat. Right.
Okay.
So so those parts on the primary side, they're all gonna run cooler because they have less current, right, going through it. That's
because I've always looked at the power supply reviews and saw different numbers, and I never studied really physics.
Yeah. So if you actually test the same power supply, same loads, But with 115 input versus say 230 or 240 input, you're going to find that the 230, 240 input's always a lot more efficient.
So the Australia is better to run power supplies in Australia.
Yeah. Well, America's the worst because they were the first with the electricity, right? So they just made a bad decision right from the start and never changed it.
So I know there's a country that runs. Which country runs 280? Is it 280 volts?
I don't know about 280. No, Japan's 100. That's hard.
Yeah.
That's hard on a power supply. It really is. I mean, there's some times where you just have a power supply and you don't even want to sell it in Japan.
Yeah.
It's 100. Yeah,
that's why I know the deltas are pretty good.
Well, exactly. So I mean, so like the only way you can sell a power supply in Japan is if it's a really good power supply because they have only 100-volt mains. It's like, whose idea was that?
And it's that ain't changing for a very archaic country in ways. So I live there. So anyway, guys, thank you guys for tuning in. We had Jonny Guru, and he was very good having you on, man. So
yeah, it was fun.
Yes, I just want to make sure. Sorry if we missed the questions, guys. Johnny's obviously only taken a little bit of time out to do a live stream, and thank you so much because I was really when Corsair said, "Oh, do you want to interview anyone from Corsair?" And I found out it was you. Yeah, I want to interview Jonny Guru because I just grew up reading those reviews and laughing my ass off while.
Well, you
got to
keep the readers reading, so you got.
Yeah, but while I was getting educated,
and that was the other thing too, is we wanted to make sure that. Power supplies can be really complicated, but we want to make it where people could understand.
Yeah, and that's
so where it's like a learning
that's
experience.
Where that sort of like the respect and the love from the community comes. So it's awesome, man. So thanks a lot. Thanks a lot for your time, dude. Awesome. And yeah, guys, we'll catch you guys. And of course, if there's some really dying questions, I did tweet out on Twitter.
Yep.
But you don't want mass people following you? No?
I don't know. It's okay. It's okay.
So I did retweet that. You can ask Jonny on Twitter. He should respond. Yeah. I mean, if you're on a plane or you're bored or something.
Exactly. Laying in the hotel room. Just,
You got a good time. Yeah, guys. If you got dying questions for Jonny Guru, sure, shoot him a question on Twitter. And thanks for tuning in. And we'll catch you guys in another tech video very soon. Right. Thanks for everyone for tuning in.
Thanks.
All right. Thanks, guys. Bye.